Okay, a couple of things about the general features here that we keep using. The special point, which was 1, -2 in these examples, and generally it's p, q. That is called the vertex of the parabola. And it's, well, wherever the origin ends up after you shift the whole parabola. The origin is a special point for the original standard parabola. When you shift it, you get this other point p, q. What's so special about it? It's the lowest point on the standard parabola, the lowest y value. Standard parabola. And if we shift that, well, it gives the lowest y value on the shifted one. Lowest y value on shifted parabola. I should make that clear. It's the 0, 0. That gives the lowest value on the standard parabola, and p, q gives the lowest y value. It's the lowest point on that graph, the lowest y value on the shifted parabola. Also, the original parabola has an axis of symmetry, that's the y-axis. And when you shift it by p units, you get the straight line, vertical line, x equal to p. That's an axis of symmetry. For the shifted parabola. And finally, x-intercepts are where a parabola intersects the x-axis. It may not do that, but if it does, those x-intercepts have to be symmetric about the axis of symmetry. X-intercepts. If they exist, are points where a parabola or a straight line, any function, intersects the x-axis. To be more precise, it's the x-coordinates of those points. But if you know the x-coordinates on some point on the x-axis, you know the point, and vice versa. Let's write that down. They are symmetric with regard to the axis of symmetry. So in the example, y is 1/8 times x minus 1 quantity squared minus 2. The axis of symmetry is x equal to 1, vertical line, with equation x equal to 1, and the x-intercepts are x equal to 5 and x equal to -3. Notice how those 2 points that give me the x-intercepts are the same distance away from the axis of symmetry, namely 4 units in this case. And that allows me another way to find this axis of symmetry. If x-intercepts are x1 and x2, say, how do we find the point right in the middle? It's the average. P is x1 plus x2 over 2. And, well, that might also help at some point if you know the x-intercepts. Let's do an example where that helps. Find axis of symmetry and the vertex of y is x minus 1 times x plus 5. Okay, so you might go through the whole rigmarole with the shifting and the completing the square, but this is a shortcut. This is much easier if you use that thing with x-intercepts. So we got x equal to -5 and x equal to 1. That's your x-intercepts, okay? And right in the middle, that number p is -5 plus 1 divided by 2, which is -2. It's a distance of 3 units away from both. And so that's going to be also the axis of symmetry. And what's the vertex? It has x coordinate -2. And the y coordinate, you need to plug in x is -2, and you get -3 times 3, which is -9. So that depends on the scale on the y-axis, the unit on the y-axis. Let's pretend it's here. We got that vertex, and the whole parabola looks like this. Much easier to find your vertex and axis of symmetry that way, using that it's in the middle between the x-intercepts. I should still mention the words maximum and minimum. We say that y is f of x has a minimum at p comma q. So that's already thinking about the example of a parabola with a vertex at p comma q. When f of p is q, and f of x is greater than q for all x that are not p in the domain. So it's got to be legal input values. But the function is bigger everywhere else. So these parabolas that I've shown you, they all have a minimum at the vertex. That is, if they are not flipped upside down. In which case it's the biggest value, that's called a maximum.